So how about spoofing something like your bank? I mean, replacing ads is, who cares, right? But what about you log into your bank and they spoof that so that your computer has a keylogger, and instead of it just going directly to your bank, it's also watching for your login. There are some things that you can do about this at the security level. Not every bank supports this, but two-factor authentication prevents the reuse of passwords, so somebody copying a password can't log in. But if they're going to build something that's going to attack banks, they may just stay logged in once you log in on their side and then do something that you wouldn't want them to do. So your computer has a signature that it can check to make certain that when it talks to this, www.bank.com site, it is actually getting the correct site. And that is the things that are checked as the web of trust in HTTPS. And it keeps a copy of these on your computer, and provided that copy is still good and those keys are still correct, it can verify that you're actually talking to the right site. That's part of what HTTPS does. The other part is the encryption. It uses that key to encrypt the data so that people can't listen in the middle and do anything with the data in the middle, like watch what you're doing. Now, the assumption in this is that this list of keys that it's keeping locally is both accurate and not corrupted, and that it is actually the original keys, which unfortunately is not always true. The government of Georgia, the country, not the state, that's right next to Russia, requires that everybody with these kind of keys actually turns over their private keys to the government so that they can listen in. Because we just know that all governments are trustworthy and therefore they never leak keys, they never lose them, and this is a good thing. Also, there's the possibility of somebody just losing a set of these private keys. Dell managed to sign some software and lose a set of private keys for this purpose a while back, and for a short period there was software that they were shipping that had the private keys embedded in it so that it could actually leak this information. To prevent these kind of leaks, the Web of Trust has systems set up to expire keys so they don't last forever, and also systems set up so that you can intentionally expire a key if you know you've lost one. But not all software pays attention to this, and consequently, there is the possibility that somebody has lost some of these keys. So DNS turns a name into an address. After it's got an address for the 90 or so things that are on a web page, it's going to then send this off to the frame cloud to do routing. Routing uses a bunch of tables and a bunch of different devices to say, these things are over here, those things are over there, and I send the packets in generally the correct direction. It's complicated, but at the end of routing, it ends up somewhere at some server talking to that server. Now, before it leaves your side of the world, most organizations, actually including my home, want to intercept your request for various reasons. Some of this is for security. Some of it is so that DNS doesn't have to go out to the web to resolve every time and you get faster throughput. Some of it is for caching so that you have a local cache so that if you pull down a particular page, it saves it. And there are tools like this one called Squid that allow you to do this very easily. It's an open source. It has tremendous capabilities for what you're going to do, what you're going to cache, and how it runs. Lots of organizations use tools like this. On the other end, after it's gone through the routing, quite often there's another proxy on the other end that also is doing this kind of stuff. So there are multiple levels of proxies in between. A proxy is a piece of code that receives a request and then turns that into a new request on the other side. Sometimes it does. There's lots of reasons why proxies get used. So you run your routing through the frame cloud. Lots of magic happens. On the destination end, the most likely thing to see is if they want their site to stay up, they use some sort of reliability proxy. There's an open source one called HA proxy that is used that has, again, like Squid, tremendous capabilities, but works on the other end usually. Or they go through some system like CloudFront, which is got its own internal proxies and DNS so that you can take a website on some teensy computer and just have CloudFront cache all the static pages and serve it at internet scale. But the sum total of these different levels of proxies is always that there's caching and that these proxies are both tracking and providing services in between. When it finally gets to a server or set of servers, the most likely thing to see is another level of proxying. Quite often this is done with a program called nginx, Nginx, where it routes stuff for that particular server. For instance, a business might have WordPress running locally or on some cloud server, and they want all the requests for WordPress to go to the WordPress application. But they also provide other things to their employees, and they have a website, and they have some dedicated tracking for something. So the requests for that need to be routed to a different server on their side. nginx can do this forward proxy routing for them. There's some configuration, but it's very good at that. And it also provides a lot of features having to do with security at the level of the destination. So it provides lots and lots of capabilities for getting the request to the right piece of software or to serve files at the correct location out off of the correct server. So what happens at the server? The first thing is that, you get routed to some program or some file gets served. And different applications have different programs. So you look at some sort of an URL like that one with index.html, and you've dealt with all of the stuff in the front side of this. Now we have some sort of communication endpoint like index.html. If you had just typed in that without the index, usually there's a default and it's going to end up there. But single page applications, this is usually the file that they're in. It doesn't have to be this. You can configure this to be other things. And there are some web servers out there that like to use default.htm, but that's not the most common things these days. And lots of devices use this same thing. If you configure a webcam that's going to watch for security, chances are the way it was written is it has a little tiny server on it. It serves web pages, and it has one of these as well. If you go to configure a router, usually the front end for a router is built this way as well. Quite often, index.html is actually a file on the server. And I'm using this term server here because that's the way you need to look at it, although it may not be a server that's out serving pages to the general web. And the way a lot of these work is you have many different pages, and each time you click a link, it brings up a different page. But there's also a class of single-page web applications where everything happens inside a single page. Single-page web applications for development and caching, since you load everything at the beginning, have lots of advantages. So it looks in some directory and it finds the page, it sends this back. The client looks inside the page and there are probably pieces like images and JavaScript files and cascading style sheets that it turns around and fetches. And all of this stuff gets rendered by some client on the person's browser, or it gets saved by some client like wget or curl to files. One of the pieces of information that comes along with this is what kind of a file it is. When it's HTML, you kind of know that it's probably going to be in HTML syntax, but there's no guarantee to that. And browsers have unusual tendencies to do things like look at the contents of the file itself and go, oh, it says .html, but this is really an image and I should display it as an image. Or vice versa. It's a JPEG, but the JPEG isn't in JPEG format. It's actually an HTML file or a JavaScript file, and I'll use it that way. So browsers have the ultimate say in how they use it, and they may do some poking to figure this out.